Is it better? Am I audible now?
No. Same thing only. Too low.
Sir, there is so much echo in your voice.
Yeah.
Okay, correct. Then my own fan is creating some noise. Is it better now? Can any of you respond? Is it better? Same thing. Okay. Yeah, audio is good. Yeah, I expect it to be better now. Someone can confirm, please. Is it better? Is my audio quality better? Or still the same?
I guess we'll have to proceed with this way.
Okay, no, and what is the issue? Am I audible or you're hearing some additional voice echo?
Sir, you are audible, but the issue is like whenever you are in an empty room, then your voice echoes. So that is actually happening with your voice.
Yeah, but I'm not in the room now.
So you're audible but not clear.
Okay, hold. Yeah, is it better now? Still my
Yes,
voice
sir.
is good? Yeah, thank you. Okay. Yeah, so welcome to today's activity session. So how are you all? Hope you're all safe and healthy. Should we wait for someone to join? We have only 10 people, in fact 8, excluding myself and the host.
Sorry, Sudarshan, your audio is too much low and then echo is coming, I think so. It's not clear.
Yeah, but just now someone confirmed that it is better.
So it came better, then
Sorry.
again the same issue like started happening again.
Then maybe some signal is not having. I'm sorry, this is the best we can get since we are all working from home. Hope it gets better as we proceed with the session. If it's completely not audible, then it's a serious problem. We have to rectify it. But if it is audible and you get some disturbance, uh, we are sorry. I think we have to cope with it. Yeah. So how are you all? Hope you are all doing good. Okay, still we are waiting for some more participants to join. So in the meantime, can anyone share your experience? Like, how do you feel after getting into this program? And how do you find Maths 1 and the other courses? Anybody there?
Yes, sir. I'm here, but sorry, I'm not like getting you properly.
Oops. Still voice is not clear.
Sir, it's better than earlier, but it's still like I'm facing an issue. I don't know about others, but yes, I'm facing an issue.
Is it only you or what about others?
Same, sir, same.
Yes, sir. Same, sir.
I think, see, volume speakers are full. Mr. Mahesh, can you help us? Is there any way, any other way to improve the sound quality?
Sudarshan, I can't do anything because it's in your system or
Yeah, I think so.
using now. In that only you have to do. Okay. I can't do over here.
Okay.
If you have any, I mean, headphone or else,
Yeah, I'm speaking.
mic you
from,
have? Do you have
speaking
mic?
from mic on. Yes, yes.
Yeah, just insert and you can try it now.
Yes, I'm speaking from there only, from the mic on.
Yeah, but it's not clear to. Okay, but now is okay. I think so. Little bit.
Okay, then we'll start the session. I think we have to 10 people joining the session so far. So, anyone wants to start with any questions from the activity questions or practice assignment, you can ask. Yeah, anyway, I think we have to move on with this session. So we can proceed by discussing some questions. Anyone is willing to ask some questions? See, people, I'm waiting to hear from you. I hope I'm audible at least.
Yes, sir, you're audible.
Yeah, please give me some response. So, how are you all?
Sir, good, sir. We are good, sir.
Thank you, sir. Fine.
Yeah, so can we start with this session?
Yeah, sure, sir.
Yes, sir.
Yes,
Now,
sir.
yes, sir.
Yes,
Now your voice is also better than before.
Okay. Should we wait for some more people to join or can we start? It's already time. We can start.
Yes, sir, we can start.
Yeah. So, anyone wants to ask some questions from the activity? Week 2, week 1, or practice assignment?
So actually, I missed week one, so I do have doubts in week one. So if week two finish like completes, then I can ask afterwards.
Yeah, sure. Like towards the end of the session, maybe last 15 minutes, we can discuss questions, queries from the from. So can anyone respond like how do you feel? I mean, how do you find this course? I hope you are all unmuted and you are allowed to speak. Since
Yes,
I'm
sir.
not
Yes,
getting
sir.
any response. See, I'm not asking any tough questions, right? I'm not asking any technical questions. I'm just asking how are you and how do you find this course?
Course is good, sir.
Okay.
Yes, sir. And
You find it easy or
Yeah, for non-max backgrounds, we are trying our best, and at the same time, our mentors also helping a lot, sir. We are very much thankful for that.
okay? So, so what about the other courses, CT and you are finding them easy? CT and STAT.
As usual, English is easy, sir, and programming. Just now we are crawling, and we want to learn how to walk. After that, we will learn to run.
Yeah, that is true. First, you learn the basics and then you can learn how to run codes.
Yeah, but the way you're supporting, it's awesome. Simply, we can say that.
That's okay. Thank you. So yeah, so you are finding the course comfortable, then we'll also be happy with
Yes, sir.
what you are
Very,
doing. Yeah.
very comfortable.
So any questions? In week 2 activity questions or practice assignments? If there are no questions from your side, then I'll ask you some questions.
sir, Aman Tiwari is asking activity question 2.6.
Which one? 2 point?
Mr. Aman Tiwari, activity question 2.6. See, sir, in
Okay.
chat, each time.
Okay, let me open it. Two point six question number.
6.
Question number 6.
Yeah. You are able to see the screen? Let me restart it.
No, sir.
Yeah, now are you able to see the screen? You can see the questions?
Yes, sir.
Yeah.
Yes, sir.
Sir, actually question number 4, sir.
Question number 4.
Sir,
Okay.
assignment activity 6 का question number 4.
2.6, right? Yeah. So if L1 and L2 are lines parallel to each other with slopes N1 and N2 with inclinations alpha and beta respectively, then which of the following is not correct? Okay. So, yeah, so we have L1, L2 lines with slopes N1 and N2. And with inclinations alpha and beta respectively. Okay. So we have this line, let us call this L1 and inclination of this line is alpha, and then let's say we have another line L2, and its inclination is beta.
Sir, L1, L2 are parallel lines.
Yeah, L1 parallel lines. Sorry. Yeah. So when we have this, we know the inclination angles of the two lines and slopes, which are nothing but slope. Can anyone say what is slope? How is slope defined with respect to the angle of inclination?
Tan of yeah.
Sorry?
Tan alpha and tan beta are the slopes.
Yeah, correct. So tan alpha and tan beta are the slopes. So if lines are parallel, what can we say about the slopes? M1 and M2?
Slopes are equal.
Yeah, correct. So what are the correct options in this question?
Option 1 and C.
Yeah, correct. So what is the issue? The person who asked this question. What is your doubt?
So
Does
actually
it
my
answer your
doubt is in second option. Alpha is not equal to beta and tan alpha is not equal to tan alpha.
Okay. I mean, what is your question on that? See, if the slopes are equal, what does it mean? If M1 and M2 are equal, you agree with that, right? Can you respond to my question? The person who asked this question, you said you have some query with respect to option 2. So in this question, it's given that two lines are parallel, so slopes are equal. So what does it mean with respect to the angles alpha and beta?
Okay, sir. Okay.
No, you can try to answer it, right? Then I will know better what is your query.
Sir, actually your
Yeah.
voice is not that clear. That's why I didn't get your question. Your question.
Okay, my question is that since one more person answered this, that when I asked what does it mean when two lines are parallel, the slopes are equal. So
Yes, sir. Yes, sir.
yeah, so their inclinations are alpha and beta. So slopes are given by tan of the inclination angles, right?
Yes, sir. Alpha. Yes, sir. Alpha beta are angle.
So alpha
So
cannot be
yeah, alpha beta are equal. It means tan alpha and beta is equal.
correct.
But
So
if sir here in second option alpha is not equal to beta.
correct.
So I think sir tan alpha is not equal to tan beta might be sir correct option.
How it can
Because
be correct if alpha is equal to beta? Okay, the inclinations. See, what does it mean by when we have the inclinations alpha and beta, and the two lines are parallel? That means M1 is equal to M2. So that means the tan of the inclination angles must be equal.
okay, sir. Okay.
So right, that's what we call the slope. That's why I asked you. Someone else answered when I asked, what do you mean by slope with respect to the inclination angle? So slope is nothing but tan of the inclination angle of that particular line.
Okay. Okay, sir. Okay. Thank you, sir.
Sir, can you please repeat again the last sentence? Your voice was a little not audible.
Okay, slope is defined as with respect to the angle, inclination angle. Slope m of a line is given by tan function of the inclination angle measured from the counterclockwise direction. Okay, that you must remember. Although in this question it's not there, but just clarifying that measured from the counter. We say this is the counterclockwise direction. So from here, so this is the counterclockwise direction, and So this is the clockwise direction. If you say this is the angle, then it's not correct. So inclination angle we define in the counterclockwise direction. So tan of that angle is nothing but the slope.
Yes, sir, get it. So actually, I was
Yeah.
confused in options that way. Now I get it.
Okay. So next, any other questions?
Sir, can we ask a question from graded assignment also?
Graded assignment, there will be a separate session on that, but I won't be, yeah, you can ask, of course, but I cannot give you the final solution. I can guide you how to solve it. You can ask.
Okay. The question 10, how to approach for that question?
Okay. Let me open. Yeah, question number. Question number 10.
Yeah.
Okay. So you're
We have to actually we have to simply apply the area of the triangle formula, no?
Yeah, that's it. If I have to
Okay,
find the
okay,
area.
okay.
Yeah. What was your doubt in this?
Well, sir, I was not getting how to.
No, it just says compute the area of the plot in square units. So plot is triangular in shape, and the vertices of the triangle are given. So use the vertices of the triangle and use the triangle area of the triangle formula. Then you will get the answer. Is that okay?
Yeah, sir. Okay.
Yeah. So any other questions in the activity?
Yes, sir. Actually, sir, same in graded assignment 2, question number 9. Actually, I didn't get the question.
Question number 9.
Yes, sir.
Okay, I will explain. So the question says it's about aircraft wing design. Okay, wing
Yes, sir.
design, we have some structural components like ribs and spars.
Yes, sir.
So it is given in the question that ribs and spars are arranged perpendicular to each other during the manufacturing of a wing.
Right, sir.
So ribs and spars are represented by R and S. Okay, and
Okay,
in the
sir.
options, the endpoints of certain structures marked as R and S are given. The endpoints are given for R and S. So for each of the options, you have to check whether this combination of R and S can be chosen for aircraft wing design. So that means the rib and spar has to be perpendicular. So endpoints are
Your
given.
voice is actually not clear.
I'm sorry.
Actually, we have to find the perpendicularity between the both these R and S, and we have to compare their slope if they are perpendicular or not by finding their slope.
Correct. You have the endpoints of R and S in each of the options. So find the slopes of R and S of line containing R and S. So once you find the slopes and check whether these two lines are perpendicular. So if they are perpendicular, then it is a correct option. That means that particular combination of rib and spar can be used for manufacturing of a wing.
Actually, in this case, spars are 2 and ribs will be 6.
Sorry, ribs will be
6 because 8 is structural parts. So I have gone through the internet and checked what is the ribs and spars.
Yeah.
So in general, spars are 2 and ribs in between on 90 degrees.
Correct.
Right, sir?
Correct.
So and they are 90 degrees.
Correct.
Both.
So when will they be 90 degrees?
Right, answer?
When will they be 90 degrees?
With the means ribs and spars, they are at 90 degrees.
Yeah, when will that happen? So you have to check the slopes of these two lines, right? Lines containing the endpoints of R and S. Endpoints are given.
Mm.
So you find the individual slopes for each option and see whether the slopes are satisfying the perpendicular condition. What is the condition for perpendicularity of two lines?
Suppose two lines M1 and M2, then M1 dot M2 is equal to -1.
Correct. So you check that condition for each of the options.
Okay,
Now you
sir.
got it?
Now I get it.
Yeah.
Yeah, now I get it. Thank you, sir. Thank you. Okay, sir. Okay.
So next. I think we have very limited number of people joining here. Only 10, I think. 10 excluding
Yes,
two of us. Yeah.
Yes,
I
sir.
think maybe this is not the right time for people to join. We thought evenings are good or convenient for people to join the live session. Either it could be
Evening.
possible, it could also be possible that people don't have queries, so they don't want to. That is also.
Yes.
Yes, sir. Actually, time is okay because in this lockdown situation, no one is going to out of home to do any
Yeah,
work.
yes. True. So we want to keep it in the evenings so that those who are busy with office work, those who work from home, they are also.
Evening is fine, sir. Actually, I think many people don't have doubt in week 1, 2, 3, 4.
Okay.
That's why they are just less people.
Yeah, but last time when we conducted this Maths 1 term 1, so we faced a lot of queries from learners from week 1. So it's good. It's good that this time we don't have that many queries. So any other questions from week 1? If there are no questions from week 2, if you have any pending queries or doubts from week 1, you can ask me.
Sir, I have a query from week 1 itself.
Yeah.
Sir, please explain the concept of equivalent class.
Okay. Yeah. So equivalent, see when you know what is a relation and when it's a relation, equivalent relation. So in the relation will be an equivalent relation, it satisfies all the three conditions. That is transitive, symmetric, and so it has to excuse me, it has to satisfy all the three relations. So once it satisfies, so I hope you know the conditions for three relations. So can anyone say what is a transitive relation?
Sorry, sir, I am unable to hear you.
Yeah, can anyone say what is a transitive relation?
Yeah, sir. If A related to B and B related to C, then A must be related to C.
Okay. Yeah. Yes. They're not exactly. The statement is slightly different. Can anyone answer this? Yeah. Essentially, it is the same. I just want to correct it a little bit.
But I think it is if A and B is there in this, then we should check for B and C. And if B and C is present in the set, then A and C must be present there.
Yeah, correct. So that has to be carefully remembered that if there is a relation, AB and where A, B, C are all belong to R, belong to a set which contains R. So if AB is a relation, and then you have BC is also a relation R, then yeah. So then A comma C must also be a relation. So if there are no relations, like if you don't have any relations to show that A, B or B, C, so the elements A, B, C, then you don't have to check the truth of the statement whether A comma C will be a relation or not. Then A comma C will be always be a relation. So I mean, so that is called proof by vacuous statement, that if there are no such relations A, B or B, C in the set, given set containing the elements A, B, C, then this statement is always true. I mean, I'm not trying to confuse you, but that is the exact statement. I just want you to understand the exact statement of this transitive relation. Yeah. So what about symmetric?
Symmetric relation says that if A is related to B, then B should also be related to A.
Correct. If A and B is a relation, then B comma A is also a relation. When you flip the elements, that is also a relation. And yeah. And what about the third relation? For equivalence, we are discussing about equivalence relation, right? So when a relation will be an equivalence relation if and only if it satisfies all the three conditions. Am I audible?
Yes.
Since I'm not getting any response.
Sir, actually, I'm not
yeah,
getting.
some
You're not
disturbance is
properly
there.
audible.
Yeah,
Yes.
yeah, some I can
Your,
understand.
your, your voice is not clear, sir.
Yeah, yeah, I can understand because I'm not getting quick responses from you. So, so can anyone answer this? How do you define what is the third relation? How do you define it? We are talking about properties of relations. We discussed symmetric property and transitive property. Anyone wants to answer? So one person asked this question that what is equivalence class and what is an equivalence relation? So we are trying to answer him. Anyone wants to answer? Hey, there is no response. Is the audio completely lost?
They're not completely lost.
Okay. Then there is no response at all. Why? Okay, I'll answer. If nobody wants to participate, then it's very difficult, right? At least something you must say that, okay, we don't know, or you please answer, or something like that you can say. If you don't respond at all, then I'll be concerned about the audio quality. I'm not audible at all.
Sir, actually,
The
I do have.
third property of the relation is reflexive, and what it is, I just want to ask you, and can anyone define it? When is a relation reflexive? So for a relation to be an equivalence relation, it will be an equivalence relation if and only if it has these properties, that it is symmetric, reflexive, and transitive. So we defined what is a transitive relation and what is a symmetric relation. So I'm asking you, when is a relation reflexive?
For reflexive, if A related to B, then A must be related to A itself.
Yeah, it's not that if A related to B, there's no if there. It's just that an element from the given set must be related to itself. So
Right.
whatever condition defined in the relation, so that element must be related to itself. That's it. There is no if condition there. So now with all these three properties are satisfied for a relation, for a given relation, then the relation can be called an equivalence relation. If and only
Sir,
if all the three.
can you give an example of a reflexive relation?
Okay. So I'm writing there. So, okay. Let's say we have this x comma y. Okay. The condition that x equal to y and xy belong to real number set. Okay. So writing is also not good here because we have a different device now. We are not in the studio. We are also working from home. We'll get trained to this, and once we get trained to this, then it will be
Okay,
better.
no problem, sir.
Yeah,
It's
because
understandable.
we don't have a direct screen to write, so we have to look at the screen and write somewhere else. So that we'll get trained to this. Sure. In few sessions, we'll be better in this. So this is an example. Can someone say that how this can be an example of reflexive relation? Can you say this relation are defined like this for the pair Cartesian pair, I mean for the pair x comma y, and
Yeah, this is identity relation also, right, sir?
sorry.
This is identity relation also, no, sir? X is equal to y.
Yeah, see, yeah. So whenever x is equal to y, so this relation goes to for all xy belonging to the real number set. So can someone say how this relation is reflexive relation, or is it clear? I hope it is clear. So this is an example of a reflexive relation. Can someone say how? Or are we discussing two basic things? It's all well known for all of you. You have to say something. Otherwise, it's very difficult for me to understand what is your thought process.
Yeah, sir. Actually, it's good who asked this question to respond.
Yeah.
I understand actually, sir.
Yeah, yes, sir. It's clear that it is an example like x and
So
y
that means,
should be equal.
I assume that these things are very basic for you people.
Yes, sir.
Yeah. So that's why you are not responding.
Yes, sir.
Okay.
I had a little doubt about it.
That you have to say, right? Otherwise, how can I? Okay.
Okay, sir.
So yeah. So this is one very elementary example for reflexive relation. Okay. So if I say that if I change this, okay. If I change this to x greater than y, so what can you say about this? Now will this relation R be reflexive?
No, it can't be reflexive. No.
Okay. Why?
Because if we take x comma x, then a number can't be greater than itself.
Correct. Correct. So if I change it further slightly, okay. Now x greater than or equal to y.
Now it can be a reflexive relation.
Yeah. So yeah. So what can you say about this? Can it be symmetric? Okay,
sir,
this
it's
is
not
also
symmetric.
very elementary for you. You are not answering. Yeah, Sarkar.
No, it can't be symmetric. Only it will be symmetric only for one condition. When x is equals to y.
Okay. So what do you say about this? What do you mean by it will be symmetric only for one condition? Either it is symmetric or not symmetric.
I'll say not symmetric
So why?
because it's not always true. Like uh, the x are so
Yeah.
x is greater than equal to y, but y is not greater than equal to x.
Yeah. So it will be true only when x and y are equal. So
Yes,
that is
yes.
only one special pair of x, y. But it's not true for all pairs of x, y in the real number set. So this cannot be symmetric.
Yes, sir.
Yeah.
It's only when x is equal to y.
So now I hope
It will be
this
symmetric.
equivalence is clear. So any other questions? From week 2, week 1, week 3 is not yet open. So we cannot talk about that. So you are all clear with injective, surjective, and bijective functions and Cartesian products, set theory, and all those things.
Yes, sir.
Yeah, good. So can someone say, okay, if I give a table, okay. Since you are not asking questions, I will ask questions now. So we have a table. I'm not giving values here. We'll just give some names and say Kori and okay. And, I hope you all watch cricket.
Yes, sir. Yes.
Yes, sir.
Then it's fine. So in Y column we have these names of countries. Okay. England. So now this X contains four elements and Y contains two elements, India and England. Now when we try to map X to Y, okay. So first of all, tell me, can this mapping be a function? Can this mapping be a function from X to Y? Or this is also very elementary for you? It's okay, you can answer. Right?
Yes, sir. This is a function.
I don't think it will be a function, sir.
So whatever you say, you have to give reason.
Sir, if what you written root and Wilson, if they belongs to England, then only it's a function. Because Rohit
Yes.
and Kohli belongs to India.
Yeah, let me clarify that Williamson, I refer to
Williamson belongs to
is
New
Ken.
Zealand, I guess.
Yeah, Ken Williamson is New Zealand. Yeah, I clarify
Yeah.
that. Rohit Kohli belongs to India and Root belongs to England and Williamson belongs to, we are referring to Ken Williamson from New Zealand. So now you said, is this mapping a function?
No, sir.
Why?
Because there should be a output for every input. Sir.
Correct. So for Williamson, we don't have it.
Yes.
If we don't have any map in the y. So we'll add New Zealand there. So now
it's a function, sir.
so what can you say about this function? Is it one-to-one?
No.
Why?
Because Rohit and Kohli have the same image.
Correct. So yeah. So is it onto? Is it subjective?
Yes, sir.
This is
It is on to her.
Okay. Why?
because every image have a pre-image.
Correct. So suppose we have instead of image, image is correct, but what you have to check for is range of the set y must be same as codomain.
Yes, sir.
Yeah. Okay. So suppose we had one more. We had Australia also. Now, what can you say about this function?
Now range is not equal to codomain.
So it's not.
This is not subjective.
Yeah. So yeah, perfect. You are all clear with the week one content. So fine. So any other questions?
Sir, I asked about equivalent class.
Sorry?
Equivalent class.
So I think we are getting some different. Sorry, somebody's phone interfering with something. Yeah, so we defined what is an equivalence relation, right? So equivalence class is not discussed in the lectures, but equivalence class is the is the class. Am I audible?
Sir, can you speak loudly?
Okay, louder than this. I'm already almost shouting. I think there is. Is it better now?
Yes, sir.
Yeah. So you asked about equivalence class, right? So it is the class containing these sets, relations with equivalence property, and that is not discussed in the lectures. So let us not worry about that. But it is important for us to know when can a relation be called an equivalence relation. So it has to satisfy those three properties. That's what we just defined. So any other questions from the graded assignment or activity practice? You solved question 2 in the graded assignment. Have you solved question 2? That ladder question?
Yes, sir.
Okay. So if everything is clear, then so any other things you want to discuss here? Any other questions?
No, sir.
Okay. Then I'll pick some random question from week 2.
Uh,
And
Sir,
then I'll ask you. Yeah, yes.
sir, yeah, week 1, lecture number 6.
Okay.
Professor saying about measuring time, reflexive, symmetric, and transitive relation. So, will you elaborate, sir, this clock display or system?
No, I cannot run the video now. You can watch it later. I cannot run the video here. You can watch the video
Yeah,
later.
yeah.
But we have explained, right? We have explained those properties of the relation. Transitive. Just now we explained. When I ask those questions, people also answer. So what exactly is your doubt on that lecture?
Actually, I couldn't understand how to relate with this property, reflective, symmetric, and transitive. Means we have the means clock, and they are showing same time, like 7 o'clock a.m. and p.m.
Okay.
How they relate to with the relation?
No, we are showing. First, we have to define a relation. Right? If you have a set containing some elements, then you have a Cartesian product. So you define a relation with some pairs of elements. So that pair we call it, for example, A comma B. So you have to define a relation first with some condition. When is A comma B a relation? It is subject to some condition between A and B. So when that holds good, then you call A comma B is a relation.
Yes, right.
So like that, we need to have a definition for a relation. So when you take two names, so you take some two names, say A and B, two for people with names A and B. So we say they are related, the relation say son, father, or brother, sister. So something we have to define.
Right, sir.
So only when we define, we can talk about a pair being a relation or not. A pair of elements, I mean.
Okay. Okay. So it means initially we have to define a relation first.
Yes, not that we have to, either it has to be given in the question or we talk about some data or something we have. So we try to identify some relations. Is there any common things between certain pairs of elements? So we try to define some relations. Like I said, x, you have some numbers, you can say x equal to y, or you can also say some complicated process where some errors are occurring. Suppose you have some 10 points in some, when you are doing some curve fitting or something like that, you have errors associated with all the data points. You have a lot of points, let's say you have 1,000 points, you have errors associated with all the 1,000 points. So you are trying to identify some relationship between points which have some such that the difference between the errors at those points, error coming from the curve fitting, are equal or within some limits. Let's say difference between the errors at 2 points is equal to some value or is within some range. So you try to define some relation like this. Then you identify which are points satisfy this relation.
Okay.
So like that, there can be a practical example in data science.
Okay. Okay.
Or when you deal with data.
Mhm. Okay. Okay, sir. Thank you, sir.
So any other questions? Okay, I will ask some random questions.
Okay, sir.
And someone wanted to ask some questions from week one. He said in the beginning that towards the end we Okay, can someone answer this second question in activity question 2.3?
Yes, sir. Origin do not lie on the line segments.
No, second one. Okay. The ratio needs to yeah, touch the line segment P and Q. So how do you solve it?
Sir, actually, we used here a section formula, and we are getting different values or equations. So that's why we came to conclusion that origin do not lie on the line segment.
Yeah. So I think you're all very comfortable with these questions. That's why
Yes, sir.
which is good. Which is good. Okay. So you know about the intersection of lines? And if I say the two lines are there, three lines are there, can you say when will they intersect or when will they not intersect?
Sir, actually, your voice is not clear. So please repeat the question.
Okay, my question is, do you know about intersection of lines, conditions for intersection of lines? How
Yeah,
can
sir,
you
if they are not parallel,
between two lines?
yes, sir, if they are not parallel, then they will intersect. So non-parallel means M1 is not equal to M2.
Correct.
Yes.
So, okay, and collinearity? Like
collinearity, suppose if there is a 3 point, means in collinear means A, then B, then C, then the slope of A, B, and AC will be same.
correct. So suppose I give you 3 points and say that let me put it the other way. Suppose I give you 3 points and say that if you find the area of a triangle based on these 3 points using the area formula, and then your area comes out to be 0, then what does it mean?
Then means they are collinear.
Okay, correct. So this is also a theorem based on linear algebra. We can prove that an area of triangle is 0. So the 3 points, the 3 vertices of the triangle, three vertices which we use to calculate the area of a triangle. So those vertices must lie on a single line. That is, they are collinear.
Yes, sir. Yes, sir. There is two way. Anyhow, we can calculate.
So yeah, fine. So that also we will discuss. Yeah, then there's nothing much. I think we expect very good performance from the learners this time.
Thank you very much.
If this is the general trend, I mean, we cannot come to a conclusion based on the present audience there. Only 10, 12 are here. So maybe others have doubts, but they could not attend today's session due to some other issues. But anyway, what I understand is you guys are quite comfortable with these topics. And what you are all doing? You are all doing some undergraduate course, or anyone who is in industry working?
Yes, sir. Actually, I'm working.
Okay. So when did you complete your graduation?
Actually, graduation I completed in 2010.
Okay, so how do you feel comfortable now? Like, you had to revise those topics again, or
I have to revise actually, sir, because there is so long gap.
okay,
And one more thing, actually, I did first my diploma after 10th, so math portion is somehow weak.
okay,
Uh, I did not complete my 12th class, 10 plus 2.
okay, but
So
still
I
you
have
are
to
comfortable
repeat.
with these questions, right? You say that you know.
Yes, sir. I'm comfortable. Actually, I'm revising the things and learning new things in mathematics through YouTube and through our the lectures also.
Okay,
So that's why now I'm comfortable. No problem.
okay, okay, good. So, do you interact with other learners?
Uh,
What
no.
is their feedback? I mean, majority is comfortable with the contents in this course. First,
No, sir.
first 2 weeks.
Actually,
First 2 weeks.
actually, we means listen to them only in live sessions only.
Okay, okay,
So I have to start. I will start, sir, to communicate with my batchmates also through discussion forum.
yeah. So no, why I asked this question was since if most of you are doing some are involved in academics or just completed grade 12 or doing some engineering course or somewhere some involved in academics, then these things will be quite easy.
Yeah, sir. Actually, for working professionals like me, we have some issues with time management.
Mm-hmm.
Actually, due to this COVID situation, I am able to join the live session. Last time, actually, I could not join any live session
Okay.
due to just
And also that you might have gone through these 4 weeks of content earlier during the qualifier also, right?
yes, sir.
So that's why I assume that these things are comfortable for
Excuse me,
you.
sir.
Yeah, yes.
Sir, please explain equivalent class.
Please explain.
So what is
Equivalent class.
equivalent class?
Yeah, equivalent class is what I told you, right? Equivalent class, we are not dealing with any examples of problems. Equivalent class. Yeah. So equivalent relation is what we discussed, and equivalence class is talks about class containing those relations and sets which satisfy those three properties of the relation. And we are not talking about any practical problems or any numerical type. I mean, any discussions on equivalent class in this course or in the activity or wherever of any session, you don't find any equivalent class. So if you want to discuss something there, you can, if you have any particular question or anything you want to ask, you can put it in the discourse. So anything else?
Sir, I have one more query, sir.
Okay.
Sir, how are integers countable?
How are integers countable? Okay. Okay. This is also explained in one of the lectures by professor. So yeah. So you have to see like how you can explain this countable numbers to, and then you have this sort of uncountable, like how you can explain infinite set of numbers. Am I audible? Any response?
No, sir.
See, mic is fine, right? It should be audible.
Sir, sometimes it's a little fine, but sometimes it means not clearly understandable.
Okay, I'm very sorry for this. Yeah, I'll try to correct it next time. But
Means actually, sir, when we are talking commonly, then we can understand what you're talking by intuition. But if
by
you are
intuition,
saying,
okay, that
yeah,
is dangerous. If you
yeah,
understand
sir.
something by intuition, then it's not.
Yeah, but if you means using some terminology or concept, then we have to listen carefully word by word. So that's not actually
Okay,
clear.
audio quality is very low.
Yes,
What
sir.
you're saying.
Yes, sir.
Okay, next time we'll try to fix this. Okay, what are the other different forms of straight lines? So in these videos, you might have seen three, four forms. Do you know any other forms of writing equation for a straight line?
Sir, are you asking something?
Yes, yes. I'm asking this question.
Actually, I couldn't understand what you asked.
Okay, so in this course, in week 2, you might have seen some forms of straight lines, equations of straight lines are discussed.
Last two words I couldn't understand.
Okay, so equation of a straight line is discussed, right? So you
Equation
have,
of a straight line. Yes, sir. Yes, sir.
correct, correct. So you have y equal to mx plus c. So that's how you write a straight line. That's one slope form is what we call.
Yes,
So,
sir. Yes, sir.
so you also have intercept form and the general form of a straight line.
Yes, sir. Yes, sir. Yes, sir.
Yeah.
Yes, sir.
So do you know other forms?
We know, sir, 2-point form and slope and 1-point form, intercept form. Yes, sir.
Okay. So can you think of any other form like you have a straight line like this?
Yeah, okay, sir.
Okay. And then a straight line will also always have a perpendicular drawn from some point. Let's say we draw a perpendicular from the origin. And we can find the distance of this perpendicular from the origin. So we call this, we mark this inclination of the line with the x-axis as theta.
Okay.
So in this form, we can write it as sine theta and cos theta in terms of sine theta and cos theta also as equation of this line. No, I'm just trying to discuss. I'm sorry. Sorry, can you come again? Can you say it
Yes.
again?
Yes, sir.
So this is normal form of line.
Yeah. Correct. Normal form. So again, some questions like this you will get in the week 3 also. And I hope you people might have gone through these things earlier in the qualifier also.
Sir,
Yes, sir.
sir,
Sorry, I'm getting some additional sound also.
sir, am I audible?
Yeah, yes.
Sir, actually, I'm having a doubt in one of the qualifier papers question, fourth week actually.
Fourth week.
Yeah, so will it be covered now or sometimes later?
See, fourth week, if you want, I can answer now, but it's not yet open, right?
Okay,
What,
sir, I'll ask later then. Fine.
what is your question?
Sir, actually, there was a question which says that there are many wires which was connected to the bridge like a parabola.
Yes.
And
Question.
yeah, so that question only actually I had a doubt. So it's fine. I'll ask in that particular week.
Yeah, it's about calculating the, I mean, you have to write an expression for the area formed by the wrapping of the wires.
Sir, actually, your voice is not that clear.
Okay, you're in that question, you have to write an expression for the area covered by the wires, wrapping of the wires. So that area expression you will get in parabolic form. You will get a parabolic function.
Sir, but how do we understand? Like, we haven't been taught the area, right, of parabola.
Not a parabola, area of a rectangle only. You form a rectangular plot by wrapping the wires. That's what is given in the question. I haven't seen that question. I'm just remembering from my memory. So we cannot open that now. It won't be nice, but I'm just giving you a hint that the question is about the question is about representing the area formed by the wrapping of the wires in terms of a parabola. So when you write the expression for area, you get some things in terms of some unknown variable x. So you get some x squared terms also. You will get a parabolic expression. I mean, an expression of parabolic functional form. Then you solve it. Whatever is asked in the question, you solve it.
Okay, so sir, actually, can we have that question later on in week 4 once?
Of course, we can have a discussion on that. We can have a discussion on that now also, but I don't want to.
Sir, it's okay. I don't want to like go against the week. That's why. That's fine. I'll come to it in the 4th week, sir.
Yeah, but you okay. This is the doubt you had from the qualifier itself.
Yes, sir. Yes, yes. Sure, sir. Thank you.
So which activity is that? Okay, that is from week 4. Okay, then. So if there are no further questions from activity or from practice assignments, I'm able to hear some voice. People are talking amongst themselves. Okay, so then if there are no further responses, we'll thank you for attending this session. We'll close this here. So we meet you next week. I mean, hopefully we'll have, yeah. So all of you stay safe, take care. And if you have any further discussions, you can always post on the discourse.
Thank you, sir.
Okay, thank you, sir.
Thank you.
Thank you, sir.